All right, complex numbers. Section 4.8 is complex numbers. The question is, what in the world is a complex number? The main deal with this is you can't take the square root of a negative number. So if you go to a calculator and you try and take the square root of a negative number, like second square root -5, right? It's going to say non-real answer. So we're going to be able to take the square root of -5, square root of negative any number we want to, because we can put this in terms of what's called a complex number. Complex numbers are a plus bi. That's called a complex number. There's two parts to it. There's the real part, like real numbers, like the capital R funny thing, like all real numbers, and then there's the imaginary part. So there's the real part and the imaginary part. And then you're like, what? And then, so it would look something like 3 plus 2i. That's an example of a complex number. You can even graph complex numbers. You can go on the real axis and you can go on the imaginary axis. So you go 3 in the real and 2 in the imaginary, and you could even graph a complex number. But that's what you have to do. Now this is an I. I don't make an I like this because that looks like a 1 after a while. I don't make a cursive I because that's too much work. I make a half a cursive I. So that's the I that I use. Okay? And so what is I? By definition, I is equal to the square root of -1. This will allow me to take the square roots of negative numbers. And then the second definition that I'm going to write down is squaring each side of this equation. So if I square I squared, then I'm squaring the square root, so it's going to be -1. So I squared is -1, and I equals the square root of -1. These are my definitions. Okay? So this will allow me to simplify square roots of negative numbers. So example 1, we're going to simplify. Okay, so what are we going to simplify? We're going to simplify a, square root of -108. So I'm going to split this up into three things. Square root of -1, square root, square root. The largest perfect square I'm going to take out of that, factor that out. And that would be 36. 36 times 3. So 3 times 36 times -1 is 108. Now I can take the square root of this and get an answer. It'll be a complex number, but it'll be an answer without a negative square root underneath there. I'm going to do this first. So that's 6. I'm going to write this down second. We just define this. The square root of -1 is the I, and then square root of 3 is what's left over. So this and that are the same thing. Okay, let's do another one. Square root of -24. So it's a smaller number, so you can see it better maybe. Split it up into three things. -1 comes out, that's going to be the I. Then 4, and then 6. So then we put this first, and this is third. So first, second, third. So it's 2i radical 6. C. It could work out nicely, right? It could be the square root of -25. Well, the I comes from the negative, and then the square root of 25 is just 5. So I'm splitting it up into just two things this time, because 25 is a perfect square. So it's 5 times I. So the -1 becomes I, and you're just factoring that -1 out so that you can go back and take a square root like we did in the past, or split it up into what you can take the square root of, what you can't take the square root of. So that's basically what the I is doing for us. Okay, the next thing we're going to do is we're going to add, subtract, and multiply complex numbers. All right, we are going to add, subtract, and multiply and divide complex numbers. So adding is first. So adding 4 plus 7i plus 9 minus 3i. This is really straightforward. All we do is add the like terms. We think of the I as like an x. We just put together our like terms. So 4 and 9 make 13. and then the 7i goes with the negative 3. So it's just literally 7 minus 3 for I. Subtract. So subtracting is a tiny bit more complicated. We're going to apply all the same rules of thinking about these in like terms and all that business, but we have to subtract instead of adding. When you subtract, you have to distribute the negative through the parentheses. You have to distribute the subtraction because you're subtracting each part. So I'm going to rewrite this again. Drop the parentheses here, 2 plus 4i, and then a negative negative would be plus 7, and a negative positive would be minus 8i. Now I collect my like terms like I did before. So this and this go together, making 9, and this go together, make negative 4i. So there's my answer. Multiplication. So we're going to multiply next. So we're going to multiply negative 1 plus 2i times 3 minus 4i. So this is just straight up FOIL. We're going to do first, outside, inside, last. So this times this is negative 3. This times this, positive 4i. Insides, plus 6i. And last, negative 8i squared. So therefore, I just treated this like an x and just multiplied things together. No big deal. But we have a definition from the page before that says that I squared is negative 1. So we're going to incorporate that. So this is negative 1, and then it's times the negative 8, which will make this positive 8. So this whole thing turns into positive 8 because this is negative 1 times the negative 8 from the definition that we had before. These go together. 8 is now positive because of the I squared, and that makes 5. And then these go together, 10i. All right. So that's what's going on with that one. Then we have division. So division is more like just simplifying a fraction. So we have 3 plus 4i over 1 minus 5i. What we're going to do is get rid of the I, the complex number on the bottom of the fraction. So we're going to rationalize the denominator, make it a rational number. So we're going to multiply by what's called the complex conjugate. It's the same binomial, but it's going to be a plus 5i instead of a minus 5i. And what you multiply on the bottom of the fraction, you have to multiply on the top. Then it's just a lot of foiling. And the reason why we do this is the middle terms are going to drop out, like the difference of two perfect squares. So here we go, lots of foiling. Numerator times numerator, denominator times denominator. And really I'm just multiplying by fancy 1, and it's going to kill the I on the bottom of the fraction. So that's our version of division. 3 times 1 is 3. 3 times the 5i is 15i. This times this is 4i. And this times this is 20i squared over 20i squared. Yes, now we're going to multiply the bottom out. 1, this times this is plus 5i. This times this is minus 5i. This times this is minus 25i squared. So I foiled those all together. All right, I squared is negative 1, so this turns into negative 1. So this is going to turn into negative 20. 3 minus 20 is negative 17. And then those two go together to make 19. 4 and 15 make 19. Then I feel like we need some random spinning here. This is getting a little bit too deep. All right, break, random spinning. Woo! Okay. These disappear, and this I squared is negative 1 times the negative here makes this positive 26, plus the 1 in front makes 27. So you might say, hey, that's not any simpler, but it doesn't have an I, a complex number, in the denominator. So the numerator does, but the denominator doesn't. Okay, now we're going to apply this to a quadratic equation. So this is the last example. So we get 3x squared minus x plus 2 equals 0. All right, so we're going to solve this with the quadratic formula. So a is equal to 1, not equal to 1, it's equal to 3. A is equal to 3. B is equal to the negative 1, and C is equal to 2. All right. Quadratic formula says that it's negative b, so the double negative makes it 1 plus or minus the square root over 2a. So 2 times the 3 would be 6. Now I got to do b squared minus 4a is 3, c is 2. So x is equal to 1 plus or minus square root over 6. Now, we got to figure out the answer to this. Whatever your method is, you've got to get the correct answer, be consistent, all that good stuff. So this would be 1, and then it's going to be minus this time 12, 24. So it's 1 minus 24, negative 23. So now we have the negative square root there. So the I will allow us to simplify this. So I'm going to break this up in the square root of negative 1 and the square root of 23. 23 is a prime number, so I can't break the 23 up into anything else, so I just break it up twice. Now if this was 24 or something like that, then I definitely would split it up, but I can't do any more than this. So answer 1 plus or minus I, because that turns into I, radical 23 over 6. And that's my final answer.